Hi everyone, welcome to this overview of the new technical cleanliness feature included in PollEx 2022.3. So, what is technical cleanliness? Technical cleanliness is defined by standards as the absence of particles which might impair production processes and/or affect the performance of a product or system. For the electronics industry, the CBEI Association established a set of standards and guidelines to ensure technical cleanliness in electronics manufacturing. Today, we're going to take a look at a specific issue mentioned in this guideline and how we can assess it with Altair PollEx PCB. Altair PollEx on its newest release includes a new feature that reports the surface area that is vulnerable to electrical shorts caused by the introduction of metallic particles of arbitrary size on a PCB. So let's take a look. Here I have imported a board on PollEx PCB. From here, we just need to go to the Technical Cleanliness window. The CBEI guideline defines a technical cleanliness classification system for PCBs, based on particle size and count. In this part of the input window, we can define the particle size in micrometers. Then, the measure-based settings set the starting point of the measurement between objects. In this case, the overlap between paths and solder mask. PollEx will calculate the distance between two objects, and if it is lesser than the particle size, it will calculate the surface area. The division scale configuration allows the user to change the level of precision for the calculation. In the drop-down menu, default values ranging from 40 micrometers to 5 micrometers are listed, or the user can enter an arbitrary value for a more precise calculation. Once we define the particle size and the division scale, we click on the Add to Analysis Queue button and repeat the process for other particle definition. Let's explore the Constraints tab. Here we can define the nets for which the test will be performed. The first option we have is to choose to exclude nets without a net name. Then we could exclude nets with the same voltage or signal because this might not cause any electrical issue. We can also prevent analysis between pins of the same component, but still perform the test between pins and other objects like vias. The user can define a region for which coding will be ignored for either the top or the bottom of the board. This is defined by an artwork layer and can be selected from the drop-down menu when toggled. We can also perform this test to a smaller set of nets if you don't want all of the board to be tested. This by using string filters and logical operators to create net groups. Now that we're done with the settings, we can choose to save this as a template to be used for future tests. And all we have to do is click Start. Now, with the test done, let's look at the results window. On the left side, we can toggle on or off the visual representation of the results and the copper and solder mask layers involved in the test. On the right side, there's a table with each calculated area and a separate tab for each particle size and division scale. Each result of the table has the net and pin names and, of course, the calculated surface area. When we click on each result, the PCB viewer zooms in the area of interest. We can save these results as a technical cleanliness result file and pull them back up when we need to. We can also generate an Excel report by clicking on the Report Result button. Here, the generated report includes the contents of each test from the queue, the settings, and the constraints. The report also includes the total surface area for each particle size for both the top and bottom layers, and also calculates the total area overlap between particle sizes. And with that, we're done with this overview. If you want to know more about PollEx, feel free to reach out to us. Thanks for watching.